Morning. On behalf of the California ISO, I'd like to welcome you to the Western Energy Imbalance Market Resource Efficiency Evaluation Enhancements Initiative meeting to discuss the analysis reports which were posted on March 25th. My name is Elisandra Casillas, representing the Stakeholder Affairs Group here at the California ISO, and I will be facilitating today's meeting. I am also joined by Guillermo Bautista Alderete, Director of Market Analysis and Forecasting, along with Hong Zhu, Lead Market Development Analyst. This presentation and other materials related can be found on the initiative webpage. Next slide, please. Some housekeeping reminders. This call is being recorded and the video file will be posted on the initiative webpage for information and convenience purposes only. The recordings and any related transcriptions should not be reprinted without the ISO's permission. The meeting is structured to stimulate dialogue and engage different perspectives. Please keep comments professional and respectful. Also, please try and be brief and refrain from repeating what has already been said so that we can manage the time efficiently. Next slide, please. Instructions for questions. We will pause for questions periodically throughout the meeting. You can raise your hand by selecting the hand icon above the chat window in WebEx, or if you've joined via audio only, please press #2 on your device. Please remember to state your name and affiliation first. You may also send your questions via chat to all panelists. If you need technical assistance during today's meeting, please feel free to send a chat to the event producer. Next slide, please. For today's agenda, after I'm finished with the welcome and introduction, I'll turn it over to Guillermo Bautista, who will discuss the load conformance impact on resource efficiency evaluation, then to Hong Zhu to discuss the flexible ramping uncertainty calculation in the Western Energy Imbalance Market, and we will close with the next steps at the end of this presentation. From here, I will turn the meeting over to Guillermo.
Thank you, Lisandra. Can you hear me okay?
Yes, I can.
Okay, let's start the discussion. Can we move to the next slide, please? One more. Okay. Good morning, everybody. Thank you for making the time on a Friday morning to go over the analysis that we have put together so far for this initiative of Resource Efficiency Enhancement Phase 1B. As we discussed early in mid-February, we were planning to take this initiative and start with an analysis phase. And we defined 3 analysis tracks, and the material that we have posted last week and we're going to be discussing this morning, this is specific to 2 of the 3 areas. One is the load conformance, and the other one is the quantile logic for the calculation of the uncertainty requirements. As we indicated, we are trying to have these midpoint touches to ensure to keep you appraised of how the analysis and the development of the analytics is going so far. And here we are right now at the beginning of April, giving you an update where we are with the progress of the analysis for the load conformance and the quantile logic. This is not the final version. This is a preliminary version that we have. For these 2 specific topics, we believe is roughly capturing the intended scope. There are a few areas that we are going to continue to expand and enhance so that when we come at the end of May, we can have a finalized version, and we will highlight the expansions and the specific new areas that we have added to this analysis. The other piece that we are still in a scope for this analysis phase has to do with the analytics related to the interaction between exports and EIM transfers. That is more specific to the CAISO. And also we are in a scope of analyzing the intertide deviation adder that goes into one of the tests. That is going to be still coming ahead, and we are expecting to have a second touch point in the middle of May, most likely by the end of April. So we can give you an update where we are with that area of the analysis. And we have posted the reports that are going to be basically the basis for this discussion this morning. I hope we can have a educated discussion about the findings that we have found and that we have had so far in these two specific areas. And if we run out of time, we will be happy to still hear from you through the written comments. We have given that possibility for this stage to ensure that we capture any concerns, any feedback that you can give us in preparation for the final analysis of this scope. With that, let me start with the specific area of the load conformance. Next slide, please. And let me start with some background. This is one specific area of interest in regards to the discussion we have had so far for the resource efficiency evaluation. This is not a completely brand new area of analysis because through the different efforts that we put together for supporting the previous policy development, the first phase that we just completed, we provided analysis on how this interaction worked out. Now, one of the references that we had in these discussions in the past was very limited in scope because that requires to do some counterfactual analysis, and we have to take the markets and run under certain configuration, and that is somehow a manual intensive work. The previous analysis relied on a very limited sample of hours, and it was focused on the critical day of July 9 and for the peak hours of our ending 1920. And we draw some conclusions out of that assessment. One of the concerns that came after that analysis was that, well, this is a type of outlier case because it was a very extreme case of July 9. We have the overscheduling conditions, so it may not be the right reference to draw conclusions in a more general context. And that is part of the limitation we're overcoming with this updated version of the analysis. We have effectively done the analysis accounting for 19 different days, and we are covering the peak hours, starting from our ending 14, going through our ending 21 in general. And this is applicable to both the HASP, the hourly ahead scheduling process, and the 15-minute market, FMM. And we have done that consistently. There may be a few hours where you can see that there are blank spaces in the data, in the metrics, because we may have run into some complications to get a proper solution for that specific hour. That doesn't diminish at all the conclusions of all the remaining hours. That is the majority of the hours. And I would say, in general, one spoiler here is that you can see that, generally speaking, the conclusions that we attained with the limited sample hold true with this expansive analysis that we have done covering 19 different days. These 19 different days were picked in two bases. One, we took the top 16 days based on the peak gross load. And we also took a sample of 3 days in the winter. They were end of January. They were close enough to the current time. And they were also picked in that reference because it's reflecting different seasonality, different load conditions, different supply conditions to what we have for the summer. The other 16 days are more focused on high load days, and naturally are going to be in the quarter 3, June, July, August, even September. These other days of January is just a extra cross-check how things hold when we look at a very light load day, like end of January, in the middle of the winter, when we still have some concerns about the uncertainty and therefore operators required to use significant conformance. So it's still fitting the concern of heavy use of conformance. With that preamble, let me go straight into this specific scope of the analysis. And everything starts with the utilization of load conformance. The load conformance is an operator action that is taken in the real-time market. It can be applicable to the HAT, to the FMM, to the RTD, and we have seen that consistently done for several years. This trend shows you, as a snapshot, the trend of the load conformance applicable for the last 3 years and 2 months of 2022 in an hourly profile. It's relevant to see the hourly profile because obviously that is the shape that we are interested in. And this is captured in a box plot. The box plot only gives you the distribution, the percentiles. The box gives you the 50 quantile of the sample. The ends of the whiskers are the maximum and minimum values that are within 1.5 interquantile. And the dots are basically any extreme values that are beyond this 1.5 interquantile. There is a dot typically within the box, and that dot stands for the simple average of the values, and that gives you a sense of how the distribution of the conformance is applicable to this market. Not surprisingly, we can see that it's steady, it's consistent through the years. We also have a very well-defined shape, and this is specifically showing the HASP profile. In the report, we have FMM and RTD profiles as well. And what you can see here is that it follows naturally the shape of the net load, where we have two humps, one in the morning, one in the afternoon. There is very little use of that in the middle of the day when we have plenty of supply. Still, there may be cases where we have some conformance to address specific uncertainty concerns. And then it max out in the peak hours. And you can see that at some point we have load conformance of 3,000 megawatts. That happened in 2020. And this just shows you that it's systemic, it's persistent, and it's been applied for several years, and the profile is there. Next slide, please. When we look at the RTD conformance, the nice shape is no longer there, and that has its root in the basis as to why we utilize conformance in the real-time market. In the HASP FMM market, the objective is to position resources to ensure that we have that RAM capability accessible when uncertainty realizes. And that is in lieu because of FRP performance so far that we have discussed in other forums. When it comes to RTD, you can see that it's more normally distributed, positives and negatives. They are around the zero, that's expected. There may be a slight trend to go up in the peak hours, that potentially be expected. And the reason of this different pattern is simply because the objective, the driver for the RTD market is different. Here, the objective is to true up for imbalances that the operators see 5 minutes to 5 minutes, or even intervals, because they are just looking at the imbalance that they see overall in the system. That imbalance could be because uncertainty realizing, but also because resources are deviating, because we have an interchange imbalance in the system. Many things happen in the real time that we need to true up these imbalances. And therefore, this is the reason you can see that less defined pattern rather than position resources just to keep up with imbalances as they happen in the real time market. Next slide, please. Now, one of the basic questions and debates that have happened in the policy discussion was related to the impact of load conformance on the Western energy imbalance market, the WEIM imports coming into California. And it was very narrow in the context of imports coming into California by EIM transfer. Based on the preliminary analysis, based on this more expansive analysis, we don't see, based on hard data, that there is a one-to-one relationship, that if there is a 1 megawatt increase of load because of conformance, that could result in 1 megawatt of additional EIM transfers. There is an impact, and that is a fraction of that load conformance. Let's move to the next slide, please. This is one of the 3 sets of the dates that we are showing just for simplicity, just to have a reference, but the other dates are represented in the report. What we see here is a very simple relationship. The trend in blue is tracking the performance, the trend of the load conformance, and that is for the HASP market. Effectively, we are adding load or requirements to clearing the HASP market by that much, by the blue trend. In turn, when we put that conformance to the system, how much of that translates into an additional import transfer into the California by transfer. I'm talking about EIM transfers. I'm not talking about hourly intertie schedules for the CAISO. This is only transfers. And you can see that there is no such one-to-one relationship. There may be one interval where you can see that the amount of transfers realized because of the load conformance may be pretty close to the amount of the imbalance, and that is for January 23rd around our ending 17. Beyond that, you can see that the additional transfer imports coming into California because of the load conformance applied to the hash process is relatively a fraction of that volume. In some cases, it's pretty de minimis. In some cases, it's a good portion, I would say 30–40%. But the point here is that it's not a one-to-one relationship. I want to make sure that that hypothesis is properly defined, that it no longer holds. It's not the case. Next slide, please. And this is quite intuitive to understand, right? If we are going and adding a load conformance to the system, effectively the market, through the market clearing process, through the optimization, is going to find the most optimal way to meet that additional load. And it's going to leverage on every single variable that is available. But this is a key point. What variables are at play that could result in offsetting that additional load conformance? Well, all what is available to clear in the market is potentially a variable that is going to be utilized. And that means if we have additional load, and forget about load conformance, if we just have an increasing load, whatever the reason is, load conformance or natural increase, it could be because we have an issue in the system, uncertainty that we have to account for. The end result is that the market is going to find the best combination to meet that additional load requirement. And the result is going to be that we're going to bring either more imports or we're going to reduce exports, the hourly interties. We could very well increase internal resources, moving up resources that are already committed, or that we can commit additional resources if they are within the time frame of the stock horizon. We can very well rely on more EIM transfers coming into the CAISO. And in some cases, as we show for July 9th, indeed, there may be a case where the market simply doesn't find any additional capacity available to meet that load conformance, and rather is going to relax the power balance constraint. All these are variables at play that happen at any time, not just because there is load conformance. And therefore, when you have load conformance, it's expected that they are going to continue to play a role in meeting that additional demand. Next slide, please. And here is the summary. If you take all this granular information of interval by interval for these 19 days and just put it all together, we can see this in two relative ways. One is the relationship between the amount of load conformance in the HASP market versus how much of that translates into an effective additional transfer coming to the CAISO. And you can see it's quite scattered through the range. We can have load conformance anywhere between zero, effectively very little conformance, up to about 2,600 megawatts. That is the x-axis in the left-hand side plot. And then in the right, in the y-axis, you have the magnitude of the induced transfer because of the load conformance. Every dot, every point that you have there is a scenario, is an interval of the hash market that tells you how much we got because of the load conformance. And the line in blue, that is just a trend, is a nonlinear regression approximation that we do based on that small sample. The shaded area in gray is the interval, the confidence interval, just to see if you were to project next time that you apply a conformance where that additional transfer would fall. And that is a 95% confidence interval. And here is the complication. That is another part of the discussion that we have during the resource efficiency evaluation enhancement. If we were to project how much additional import transfer we're going to get once we apply a specific value of load conformance, the answer is not very straight. Because let me emphasize, for instance, this with a very obvious case. Let's take, for instance, the value of a load conformance of 2,000 megawatts. That is the value that is right there in the y-axis. If you can see the collection of dots for that specific vertical line at 2,000 megawatts, you can see that the dots are scattered through a wide range. They can go anywhere between about 100 megawatts, 0 megawatts, all the way to 1,500 megawatts. That means, depending on the case, depending on the specific scenario that you are analyzing, anytime you apply a load conformance of 2,000 megawatts, the outcome could be anywhere between 0 additional transfer up to 1,500 megawatts of transfers. And this is a wide range, and you can have dots all across the spectrum. So there is not one single relationship that holds fixed across the market. And that's quite expected, I would say, because obviously it's going to depend on the day you are dealing with, the conditions you are dealing with, not just for the CAISO, but across the EIM footprint. So it is hard to say that there could be a single relationship that you can derive that is going to hold true across the spectrum of different days, different intervals for this load conformance assessment. If you were to rely, let's say, we're going to rely fully on this regression line, basically saying we're going to take the points of the regression line, the blue line, to make an approximation of this is effectively what we're going to apply. And let's say we were saying for a load conformance of 2,000 megawatts, this is hitting about 500 megawatts of import transfers. If we were to say, well, moving forward, anytime there is a load conformance of 2,000 megawatts, we are going to do something to account for 500 megawatts of transfers. Well, I can tell you, if you look at these dots, half of the time you are going to be overshooting, and half of the time you are going to be undershooting just because it's in the middle of the spectrum. So it doesn't give you any meaningful outcome if you just go with the approximation of this regression line. On the right-hand side, we have the same information, but organized in a different metric. This is based on the percentage. So if we were to apply a given load conformance to a given market, what percentage of that load conformance is applicable or translated into a EIM transfer? And you can see it's obviously the opposite. The larger the load conformance, the lower the share of that translated into an additional transfer. And the same holds true as we discussed in terms of the absolute relationship of megawatts. It is hard to see that there is one single point that is going to be right for any combination of conditions given the market that you want to analyze. With this, let me pause, and I think we have a couple of questions on the chat, and maybe we can go through any others that we have on the line.
Sure. I do see a couple of callers on the phone line. Moving on to the first caller, please go ahead. The line is unmuted.
Good morning, Guillermo. This is Alvis Faboda over at PG&E. I think what you've presented is, is quite persuasive. The way I would reflect what you're saying is that load conformance over the course of time can be used for multiple purposes, or at any rate, it can be addressed with a variety of tools in the market or a variety of resource categories in the market. It would seem to me that as you approach scarcity conditions, however, you would expect that EIM transfers would tend to be in a sense, the resource of last resort, because they'd be the sort of the slack variable in the real-time market in terms of what can be brought into a system that's in a shortage condition. And that, that if you were, it's sort of like with spinning reserves, when thermal units are actually on the margin, there's a very strong relationship between spinning reserve prices and energy prices. Other times there's very little relationship. And here as well, I would think that in cases of scarcity, the relationship might be actually very strong. What do you think of that? take on it.
Yeah, and I don't have in this presentation, or let me see, can we go back in one slide, please? Because we covered these very tight conditions, Alba, and that was originally the scope that we presented in the policy development of July 9.
Right.
And you can see that even on those cases, there is no such a strong relationship to hold one-on-one relationship. So even under that extreme conditions, it doesn't translate fully into an additional transfer. And
okay.
again, that makes sense.
Would you argue that that's because there were still, because essentially there's more slack than just the EIM transfers, or is it because the EIM transfers have a varying level of availability, or what do you think would account for that? Because it seems logically that would be the case, that you would end up relying on those EIM transfers as you got to scarcity.
Well, I would say this goes back to the very basic of the market, right? This is a centralized market and it's going to take into account all the moving pieces, and that includes not only the bidding information, how expensive some resources are, but also the resource characteristics, how far they can ramp, whether they are available, whether they can be committed. It's hard to prescribe what the outcome should be without having into context how the overall footprint market condition is. And at the end of the day, we're running a very complex centralized market, and it's finding every corner possible to be able to meet that additional demand. So, and that is really the point I want to take home, that is almost a futile exercise trying to a priori define what the relationship is going to be, because the conditions are going to be completely different from one day to the next, or from interval to interval. Trying to come with this prescribed approach of what the relationship should be or why it should be in a certain way, I think it's going to be no more than a futile exercise, just because it's a centralized clearing process. Okay,
fair enough. So you're basically saying that you're showing here there's no strong relationship in general, but you'd actually go further and say there's not even a strong relationship in scarcity conditions.
Correct.
Okay, thank you.
Yeah, we have one clarification. Yeah. Sorry, let me just take one question that I got in the chat, and that is, what is the granularity that we use for load conformance? The granularity goes along the granularity of the market we are dealing with. If it is a 5-minute market, the granularity of the load conformance is on 5-minute basis. So you can effectively change on 5-minute basis. If it is 15-minute market or the HASP market, the granularity is 15-minute basis. So it can change as frequently as 15 minutes. Okay, with that, let's go to the next question, operator.
Sure, please go ahead. Your line is unmuted.
Hi, Guillermo. This is Libby Kirby from BPA. I have a question about this graph. For the values you're plotting, are these the absolute value load conformance and transfer change, or are these sort of like the incremental from the previous interval? And the reason I ask is, in your example where you're looking at a conformance of 2,000, and some of the transfer change, let's say, some of them are hitting around 500. If the load conformance, the previous interval was 1,500, and the load conformance in this interval is 2,000, then that would make me think that an incremental transfer change of 500 is 1-to-1. And so I'm curious if all of these are absolute, or if either of them is incremental, or if both of them is incremental.
Sure. Yeah, that's a very good question, Laura. Let me explain this way. Every interval is analyzed on its own. There is no dependency when we do the counterfactual of what happened in the previous interval. So when you see a load conformance of 2,000 megawatts, we are really looking at the absolute load conformance that was applied to that specific interval. And the y-axis, the additional transfer or the transfer change, is relative to the case where we didn't have load conformance. So the delta, the incremental change that we're assessing here, is not between intervals, it's between two cases. One is when we have the original conformance applied, 2,000, versus the case where we didn't have any conformance, because we want to really assess what is the impact of having the conformance. So it's not an incremental change between intervals.
Okay, great. So y-axis, when it says change, is relative to no load conformance, not relative to the previous interval. So my example of 2,000 versus 500 is not is not going to lead us to think that it's one-to-one if we knew that the previous was 1,500. Thank you.
Yeah. Operator, do you have any other question?
Yes, I do see one more caller in the queue. Please go ahead. Your line is unmuted.
Hey, Guillermo. Dan Williams from Customized Energy Solutions. Hopefully just a quick question on follow-up on that prior chat question that someone submitted. So does the HASP granularity being 15 minutes, by that I assume that you mean that, so if an operator is looking at the next hour, they could put in sort of a increasing conformance across the 4 15-minute intervals for that hour. Is that correct?
And I would tell you that that is one of the items we have discussed in the past. Even though the flexibility is there, the capability is there for them to do that, typically the load forecast is like coarse approach. So they may go in chunks, in blocks, and that is the reason indeed you can see when analyze the x-axis, you can see very discrete chunks of load conformance, right? It's not a very continuous range of load conformance. You have only vertical lines of dots accrue at specific lines like 2,000, 1,500, and 1,700 because they go in this discrete fashion. So for the flexibility is there, but typically they may go more coarse than just interval by interval.
Okay. Thanks for that. I have a couple other questions, but I think I'll save them for later after I get through more of the report. Thanks.
Thank you. Okay, let's move on to the next slide, please. Okay, with that reference, I think we have reached a very clear conclusion of this relationship between EIM transfers and the load conformance. The other path area that we want to analyze is the implications that the load conformance may have on the capacity test and the flexible ramping test. As you can see through the report that we have written, and we are going to summarize here, the use of the load conformance in either the HASP or the 15-minute market doesn't show any additional or enhancement capability for the CAISO to pass the capacity test. And we don't even have to have data to prove that. As simple as the basic design that we have in place for the capacity test, explicitly the EIM transfers are not an input to the capacity test, as simple as that. What we are showing here with all the data is any potential implications that we may have. But as simple as it could be just going into the basics, the transfers are not an explicit input that are considered for the capacity test, either for the bid range or for the requirements. Now, let's move to the next slide, please. What are the inputs that go into the capacity test? Well, we have to have the bid range, and we have to have the requirements that is on the other side of the equation. For the requirements, we have to rely on the forecast, and that is going to be the forecast that is utilized for each of the intervals that we have to assess. Now, for the bid range, there could be different type of resources. They could be internal resources, there could be imports and exports, and they are going to consider all together because the end result here is to assess how much capacity is available. Now, the capacity that is going to be available has to take into account any utilization of that capacity for other purposes. For instance, capacity that may be utilized or reserved for ancillary services is not accounted for, so we need to have that information in place. We also have to take into account the rates and re-rates to ensure that it's only the feasible capacity that make it into the system. And for the requirement, we also have this other that is to account for the intersite deviation, historical deviation that we have. And in that case, we have another area of analysis that we are going to continue to work, that is to assess the accuracy and the correctness of utilizing that current logic using a histogram. And in that sense, you can start getting a picture of what we're really talking about in terms of the capacity that is made available for the test. Next slide, please. And this is a very simple illustration to make the point. When we have a test that is a very simplified concept of, do you have enough capacity to meet your obligation? On the left-hand side, you have that capacity, the supply side. That is the summation of all the resource capacity that you may have available. And that can be grouped into generation, internal resources, or the net schedule interchange. On the right-hand side, for simplicity, we will focus only on the load forecast requirement. And it's a very basic accounting logic. Do you have enough to meet your obligation? In the past, we have discussed this in detail, and we came with the concept of explaining this in two relative fashions. One is in incremental terms, that is typically the result that you see through the test performing, or in terms of the gross calculation. That is more intuitive to understand, because when you go into the incremental, you can start getting very counterintuitive values, because the delta in some cases may be negative. And if we go back to the very basics of what is the capacity test, it's simply give me enough capacity through your supply to meet my load obligation. Next slide, please. And in terms of what is the capacity that makes it into the bit range that is assessed as available, as I indicated, we have to take into account the capacity that may be available but is not made available for the test on its own. And that has to take into account any re-rates, because that shrinks the bit range. We also have to take into account the capacity that is reserved for procuring reserves or spinning or regulation in either direction. What is left, that is the darker blue section, is indeed the bit range that is accounted for in the capacity test. This is the concept, this is the design, granted. Historically, we have seen that we may have a couple of issues here and there, and we were transparent about when those happened. That, for instance, one of the significant events that we have in 2020 was that the rates were not properly accounted. So we were over-accounting that capacity that we shouldn't. That was a defect, incorrect calculation rather than an explicit intended design. And I really come short of other ways to explain that by design, the capacity test has no influence by the load conformance, simply because there is no effect on that term, and there are no accounting of the transfers for the capacity test. Let's pause here and see. I think we have one question on the queue.
I do see a couple of callers in the queue. Moving on to the first caller, please go ahead. The line is unmuted.
Guillermo, this is Libby Kirby from BPA again. I have one question. So my understanding of the way the capacity test works for like non-CAISO EIM entities is within that bid range, right, you have a base schedule, and you're being measured up and down relative to that base schedule. And my understanding is for the CAISO, the sort of equivalent to a base schedule is coming out of the 15-minute market advisory schedules. And in this deck, we're talking about the FMM, like the load conformance being used to position resources. So I would think that because the load conformance is being used to position resources, it would have an impact on the capacity test, because it's going to move the quote-unquote base schedule of that resource if you're trying to free up capacity. Admittedly, I think it's only going to free it up in one direction or the other, right? It's going to like help you in ink, fruit you in deck. But I would think that that is going to feed into this, where the resources are positioned based on that load conformance. Can you explain that a little further?
Yeah, I really appreciate this question, because I think this has been precisely the point of confusion. Let me go back. Can we go back one slide, please? Yeah, and I would like to focus on the right-hand side. And that is the reason we have this discussion in the past about incremental versus gross. The incremental, as you rightfully indicated, relies on a starting point, and that is the basic scale for the IM areas, and that is the last FMM solution for the CAISO. But if you take that lower line, and that is denoted with the symbol S sub K upper B, just to indicate that is the supply, that is the reference line for the CAISO that we consider to be the base schedule. Look at what would happen if I move that line up or down. It will only change the relative quantity of the incremental value. It will make it larger or smaller. It's just going to shrink it or expand it. It doesn't change the upper point. The capacity is still there. Whether you define that capacity to be in base scale or incremental doesn't matter for the capacity test. All what you care is how much capacity you have in total. So let's say if you take the left-hand bar, that is the blue and the lighter blue. Let's say you have a resource, and that resource without load conformance is dispatched. Let's say the resource has a Pmax of 100 megawatts. With no conformance, that resource has a base scale FMM solution, let's say of 50 megawatts. What is the capacity that is made available for the test? 100, that is the Pmax. That Pmax is divided in 50 megawatts of the base scale and 50 megawatts of incremental. Let's say now that there is a load conformance of 20 megawatts and all that is absorbed by that resource. And that is going to move the dispatch of that resource from 50 to 70. What is the capacity that is made available to the capacity test? It's still 100. That 100 is composed of 70 of the base scale plus 30 of incremental. The solution of the FMM doesn't change the capacity made available in the capacity test. It only changes the relative composition of that capacity between what is base versus what is incremental. But it doesn't add or subtract capacity to the overall resource.
I think I understand that, except that it sort of seems like from that perspective you're counting the whole bid range as one piece, but the test is incremental and decremental. So I would think that line of where you're considering, like this looks like you're saying it's from 0 to 100, and somewhere in there's this incremental piece, but the test is separated out on Inc and Dec. And so it would make me think that you're not looking at it from 0 upward for all of it. You're looking at it from some midpoint and allowing a piece of that to be Inc and a piece of that to be Dec. And maybe I'm not quite following if what you said fixes that.
Well, I have to clearly say that there is nothing to fix here because, again, the capacity test is simply looking at the overall capacity that is made available. This construct of incremental against the base scale is just a relative construct. Whether you move that point is not going to change the capacity that is made available.
I guess my point is that it doesn't change the entire capacity, but it does change what is incremental capacity and what is decremental. Sorry, I shouldn't use the word incremental. What is upwards capacity and what is downwards capacity? And because you can fail or pass on those separately, it feels like that could influence, if you're going to fail on the upwards but not the downwards, you would want to adjust that midpoint such that you have more up instead of more down, and that load conformance could help you do that. Not that that's necessarily a bad thing. I'm just trying to understand if that's true or not.
Yeah, and keep in mind, this incremental context applies not only to the supply side, but also to the demand side. So it's a relative movement that remains constant once you see the two sides of the equation.
Okay, I guess
okay.
I'm going to have to think about it a little bit more. Thanks.
Sure, thank you. Let's move to the next question, please.
Please go ahead, your line is unmuted.
Thank you. Good morning. This is Jeff Spires with PowerX. Hi, Guillermo. I just wanted to provide a few thoughts about this. First of all, we very much appreciate the analysis that you've put together here and the amount of detail. This has been very helpful to understand more of the details around load conformance, including the impacts and some of the other days that you're looking at. And I think the first thing I just wanted to say is that we recognize the point that you've raised here as well as before, that load conformance doesn't result in a one-for-one increase in EIM imports into the CAISO BAA. And I think that we understand that, and as you pointed out, your data does show that. but I think the issue is, from our perspective, on the other hand, load conformance is being used to address some operational need for either capacity or flexibility that system operators in the CAISO see as necessary for reliability. And those needs, those capacity or flexibility issues that they're seeing and that they're using load conformance to try to address are being met, at least in part, by additional EIM imports. And that, because of that outcome, that does impact the EIM in terms of the solution and the dispatch and pricing, unit commitments, etc. And that, from what we can tell, includes at least some of the days when system conditions are tight and EIM supply is what looks to be potentially nearly fully exhausted, with a significant portion of that supply being delivered to the CAISO BA. And so there are repercussions of this, including for those other BAs potentially seeing their resources essentially fully pinned at their maximum production in those tight hours. And I think the issue that we're struggling with here is that whatever those needs are from a capacity and flexibility perspective that the operators are trying to address with load conformance are not being reflected in the test. So I think the conclusion that you're drawing here, that the load biasing is not helping CAISO pass the current test as it's formulated, is not recognizing, I think, what is a different way of looking at the problem, which is that the current test is not reflecting the capacity or flexibility challenge that the CAISO is attempting to address in the first place. And so we're not stuck on just including load conformance one for one into the capacity test, but we do think that we need to understand and quantify what is the capacity or flexibility issue that the operator is seeing, and to what extent is that issue being addressed through EIM imports and load conformance, and trying to understand that better. It seems as though that's really what should be reflected in an appropriate RS test, because as I mentioned, there's clearly some need, and I recognize that there's some complexity that need is being met in multiple ways, whether it's imports or repositioning internal resources, but there's clearly some reason that the load conformance is being used to meet those challenges, and that is not in the current test. And I think that's what we're trying to get out of this type of analysis. So I really appreciate all of this work, but I do think that there is more that could be done to try to understand better, what some of those additional challenges are and how they could be reflected in a test to make it as accurate as possible.
Yeah, thank you, Jeff. And I can tell you that we're not done yet here. So we are going item by item. I want to make sure that we fully assess the hypotheses that are shown on all this space. So I really want to go one by one. And at this point, we're going into the load conformance, and you rightfully said that we still have to do the analysis of the implications of the load conformance with the EIM transfers and the hourly intertie scale. So that is still to come. So for this discussion, I would like to boil down into what we are within the scope of the analysis that we have done so far, and I appreciate your input.
Okay, thank you, Guillermo.
Thank you, Jeff. I think we may have a couple of other questions. Let's try to go quickly on that, please.
Okay, sure. Please go ahead, your line is unmuted.
Hey, Guillermo, Dan Williams from Customized Energy Solutions again. I'll try to make this quick, but kind of following, but in a little different direction than where Jeff just went, is just to kind of continue to ask about, what is going on in the hourly intertie market, and sort of how has that changed over time, and to be impacting sort of the usefulness, I guess, of what operators are able to achieve with load conformance. And if we were to take away the availability of EIM transfers, then it's more straightforward for CAISO operators. They increase the load conformance and they either get additional hourly block intertie imports or they get increases on internal generation, and both of those are sort of helpful outcomes for what they're trying to achieve. But it seems like now with the availability of the EIM transfers, then you have this sort of additional uncertainty coming in where they put in a load conformance and they're not sure what's going to happen from that, and what happens, I guess, is based on sort of how the different types of supply are bid into the market, and then how the market clearing treats those. And so the natural question then for me is why is the market selecting EIM advisory transfers in front of hourly block imports? And I guess that's just the simple answer has to come that the hourly block imports are priced higher or are not available, or else the market clearing would be selecting those intertie imports instead. So from there, then I guess the next question is, why is that happening from a either price performance or price formation type of perspective? And that gets into questions of the kind of bid basis of them, different assessments of risk that have to happen because of the repricing risk between HASP and RTD, and just a whole host of other issues. So I hope after we get through some of this dialogue that's going on just in a EIM RSE specific basis, that we can kind of expand out into looking at what's going on then with the intertie market and how that may be impacting this situation as well. And so a data point that I think would be good there would be to look at on these times where you're seeing either higher or lower amounts of the EIM advisory transfers materializing following the load conformance. What was there in the as far as the hourly block intertie bids? Was it that there was a lack of them? Were they priced higher? Those sorts of things, so we can kind of get the more full picture of the supply that was available, and then why the market selected one versus the other.
Yeah, thank you, Dan. And I can assure you we are looking into that, and that is indeed the track 3 of this effort that we are going to put together for the next round.
Okay, so that's part of being tied in with the export transfers, is to look also at the import side of that as well. Okay.
Yes.
Great. Look forward to seeing that. And again, very helpful presentation, and really appreciate your team's work on pulling forward all this data.
Thank you, Dan. Okay, let's move quickly to Libby, please.
Please go ahead. Your line is unmuted.
It sounds like a tech issue. I thought I put my hand down, but apparently you can still see it. But I'm good for now. Thanks. Thanks, Guillermo.
Thank you. Okay, let's move to the last topic.
Sure, but I do see one comment and one question in the chat. Would you like to take that?
Let's just move forward, and I can take back at the end, please.
Okay, sure.
One more. Now let's move into the flexible ramping test. That is the other area of concern regarding the impact of the load conformance. As you can see through the analytics that we put in the report, and sorry, I had to put some math there to justify the logical explanation that we are putting this with illustrations. And the math doesn't lie. You can see and walk through the derivation that we put in terms of how that flexible ramping test is impacted by the load conformance. And what we have done, based on the analysis that we have collected so far, is that the same thing as we indicated for the capacity test. The conformance of the HASP and the FMM market is not showing to enhance the ability of the CAISO to pass the flexible ramping test. And I would like to connect the dots to questions from BP were earlier today, that by moving the the FMM solution that could actually create more opportunities for the CAISO to pass the test. Actually, I would say it's the other way around. It's the contrary. It's actually detrimental to the CAISO, and I'm going to explain that. Let's move to the next slide, please. This is a comparison of the load conformance against the 15-minute market solution that is utilized as the base or starting point in the flexible ramping test. Out of the 4 15-minute market intervals that we have for every hour, one of them is going to be the reference that goes into the flexible ramping test to calculate and run the assessment of the test. What you have here is effectively the implication of the load conformance for internal CAISO resources. So when we have a load conformance of 2,000, 2,500 megawatts, the portion that you see in the different bars altogether is the incremental movement of internal resources because of the load conformance. So let's put an example, September 9, the upper right corner. The maximum value of load conformance is 2,500 megawatts for our ending 18. For that conformance, effectively, we have incremental dispatches of internal resources to be about 1,800 megawatts. So by putting an additional conformance of 2,500 megawatts, internal CAISO resources have to move up by about 1,800 megawatts. Why is that important? Well, first, because it goes against the hypothesis that was discussed in the earlier discussions of the RTD enhancements, that by the load conformance, we were creating headroom in CAISO resources so that it could have more capability available for the flexible ramping test. That might happen here and there for one resource. Overall, system-wide, you can see that it's actually the contrary. By having load conformance, we are not creating more headroom in the resources of the CAISO. We are cannibalizing those capabilities of internal resources because now we dispatch those resources up. And therefore, now when we go into the flexible ramping test, we are going to start with more limited capacity for the test rather than more capacity. Let's move to the next slide, please. And this is very intuitive to explain with this illustration. So the flexible ramping test is assessing the capability to ramp from the last available interval that is called T-minus 7.5 up to each of the 4 intervals of the hour that is being assessed at T plus 7.5, T plus 22.5, and so on. So let's assume just with the M that you are talking about one of the 4 intervals of the hour. When we start the ramp capabilities, how fast the resource can move from a given starting point all the way up to its capability in the next interval, in the subsequent interval, or in each interval of the hour. And that is highlighted with the trajectory that goes from the blue dot at T minus 7.5 all the way to the line at T plus M. And the portion in green, that range in green, is effectively the ramp capability that is assessed for that resource. It is relative based on 2 points. Where is it starting to be assessed? That is the last available solution from the FMM. And the resource characteristics, the speed it has, how far it can go, how fast it can go. That range is effectively what is utilized to assess the test. There could be a portion that is still available. It has a still headroom that could go up more. It simply doesn't have the capability, the speed to reach that extra capacity. And for that specific interval, it's not accessible. Even though it's there, it cannot run fast enough to fully utilize that extra room. And potentially that extra room is going to be utilized in the next interval. So this is in general the concept of how we assess the ramp capability in the flexible ramping test. Let's move to the next slide, please. And this one is a bit crowded because it has the 2 points of reference, with and without load conformance. We explained already without conformance. That is the starting point, the blue dot. The range in green is the ramp capability that you gain by just moving the resource at full speed. When we have load conformance coming into the FMM that is utilized as the starting point of the ramp capability test, And if that load conformance resulted in increasing dispatches for those resources internal to the CAISO, the blue dot is going to move to the purple dot because now it's dispatched higher. And we see that that is happening indeed across the board. In the case that I explained, load conformance of 2,500 megawatts resulted in the blue dot moving to the purple dot by 1,800 megawatts system-wide. When we move that starting point, that is the new reference to calculate the ramp capability in the flexible ramping test. Now, if the resource is dispatching a very low loading level, potentially can still gain access to the same ramp capability defined by green. But when you are in tight situations, it's likely not the case. Most likely, because you move already the resource up, it's going to hit prematurely the upper economic limit. That is all the capacity that is available. So you can see that there is a trajectory with dotted red line. That is ideally the full speed capability that the resource has if it has enough room from above. But because it's going to hit first the upper economic limit, that capacity is not going to be as much as it used to be with the lower point. The portion in purple, it be that now that is effectively the capacity that is available for the ramping capacity test. And that purple portion is going to be actually smaller than the portion in green with no conformance because now we are hitting the upper limit prematurely. Effectively, the load conformance in this case is implying a loss of ramp capability in the test for the CAISO resources because they already consume that capacity by using the load conformance in the FMM solution. Effectively, the range in red is capacity that is already utilized, consumed, and is not available in the flexible ramping test. So contrary to the hypothesis mentioned before, that the load conformance creates room in CAISO resources to allow him to pass more easily the flexible ramping test, is all the opposite. Using the load conformance in the FMM market eventually is leading to less ramp capability in the flexible ramping test for the CAISO. Is detrimental to the CAISO position. And effectively, this means that indeed the load conformance is already factored in to some extent in the flexible ramping test. I didn't put the derivation of this in the presentation, but you can read at your pleasure. There is like 2-page mathematical derivation of how this works. And this is basically the same illustration that you have here with this plot. Next slide, please. And this is just the summary of basically what I have explained. Let's move to the next page. Okay, so let me pause to see if there are any questions before this. As I indicated, we are still in progress in this analysis, but we wanted to give you an update where we are with this part. There are still areas to analyze, and we will continue to do that for the next round. I don't think we have any question in the queue. So because we're coming short with time, and I want to give as much time to the next topic, equally important, please let's move now to the second topic, that is the quantile calculation.
Guillermo, it looks like we do have one caller in the queue.
Okay, let's take it quickly so you can move, please.
Sure, please go ahead. Your line is unmuted.
Guillermo, it's Libby Kirby from BPA. I'll be fast. I guess the thing that's confusing me is my understanding is, earlier in the presentation, it pointed out that the point of this is to help position resources. We've said that doesn't impact the capacity test, and it's a detriment in the flex test. So there are some things I'm confused about in the flex test. I would think it would help you if you're trying to meet an absolute point that you couldn't have met because of like ramp rate capability limitations, and that's why you're trying to do it. But it's sort of lost on me, and we can address this outside since we're trying to move fast, but it's sort of lost on me. Either it's helping you in the FMM because you're trying to meet some absolute point you can't get to with your ramp rate constraint, or it's detrimental, and at the point that it's detrimental, it was said in a meeting a while back with the DMM, I think, or maybe the board, that it's not about actual load that's going to show up, it's about positioning your resources for ramp issues. And so it's sort of lost on me how we can say it doesn't help in the capacity test, it doesn't help in the flex ramp, and it's not about meeting actual load. If so, then I'm lost on me why it's happening at all. Otherwise, it seems like it could be helping you in the flex ramp test. Again, not necessarily from a total capacity standpoint, but from a ramp, like being able to meet not just the delta ramp, but trying to meet a specific load point or a specific, an aim in the future. Again, we don't necessarily have to address that whole thing here, but that's where I'm still a little lost on this piece.
Yeah, what we just summarize, and I think we need to move forward, is that part of the description that you put is right on, because effectively the load conformance is positioning resources in the FMM market or in the HASP market. But by virtue of already positioning those resources that up, it already utilizes that ramp capability that now is no longer available for the flexible ramping test. That is the piece that we have to keep in mind. It's not infinite amount of capability that we are generating. It's a matter of where you utilize that capability. And if we already utilize it in FMM, consequently, it's not going to be available in the test. Thank you, Libby. Okay, so let's move to the next topic. Thank you for the questions and the feedback. Hong, all yours.
Hong, please make sure you unmute your line and then proceed.
Oh. Can you hear me?
Yes, please go ahead.
Okay, thank you. Next topic is talking about the flexible ramping uncertainty calculation for all the EIMs. So ISO had a proposal a few years ago. Then we recently we ran a simulation study, and this is mainly reporting the findings of from that study. And before we reporting the general conclusion, and we are going to introduce a few concepts just in case, but they're going to be very brief. And the next slide. So this is the topic, kind of running out of time. We have so many. So some of these will be very brief. And basically you have summary, you have what's uncertainty, what's the histogram approach, that's current calculation, and what do you mean by weather information, how this new proposal using the weather information. Then we're going to introduce the quantum regression, that's kind of spatial regression. And then we go to the component of the net load. Net load is equal to load minus wind minus solar. And we want to see what's the uncertainty for each load. How can we take any pattern existing in those components, which is the main part for the to construct the mosaic model. Then the next is the simulation study, and we're reporting for each EIM in the paper we published. We have selected a day for each EIM to see how can you feel what the new proposal will change in how adapt to the weather conditions. Then we have general comparisons, and there are more considerations or enhancement is in the planning. Next slide. So the executive summary is like this: is the mosaic model, which is what the ISO proposed model, and the conclusion is we can incorporate the weather information to estimate the uncertainty requirement. And the reason for this put a very topic is 2 years ago is hey, currently the ISO's histogram approach does not have any weather information, whether today is sunny or cloudy. You have the same, pretty much the same the requirement, which does not make too much sense, and that's a priority, and push to the ISO and say, hey, we need a new product. So that's the main driver for this new proposal and for this study. And the conclusion for this study is, well, we have the similar coverage and have on the average, the requirement is a little less, not much, just slightly less. And they're closer to whatever the requirement is to the observed uncertainty. Then the exceeding number is the breakthroughs. They pretty much is very similar, and it offers the less reduce the seasonality of the requirement. So we are going to go to these little details, what type of the mosaic model is, and we take it from a very simple example and to get everybody on board for what that proposal really is. Go to the next slide. So and here is the external BRS, and the people or EIM can really duplicate what it is. So the proposal is and run the parallel study and to get familiar with this methodology, mosaic methodology can do. And go next slide. And all these are the notations, like the load is load uncertainty, wind is wind uncertainty, S is solar uncertainty, and RTD, RTPD. I think this is just for completeness. Everybody in the audience should have, I just assume they have this, what's the flex up, flex down, and all those. Okay, go next slide. So now this is the starting the, after all this kind of high-level summary and the notation and all those, this is substance of what we are talking about today. Today we are talking about the deflector ramping uncertainty. The study is focused on the two markets from the RTPD to RTD. The RTD itself has the uncertainty from the advisory to binding from RTD binding to the advisory. And also the day ahead of RTPD, but these studies only focus on this RTPD 15-minute market to the RTD market. So the variation uncertainty is defined as RTD binding forecast and minus RTD advisory forecast. And we have two markets in study, and we have three components. One is the load, wind, solar, and the main focus is the net load uncertainty. And we trying to, the mosaic model is trying to how directly analyze the pattern from each component, load, wind, solar, what type of uncertainty pattern we can observe, can take advantage of. Okay, go next slide. So this is the example. This is just the example. I need to say 3 times. This is just the example. Is hey, we have the whole year of data from the last year, and what will be the requirement we needed to cover the up 95% and not up 97.5%, and not for next day. So why I say that's the simplest example, because we are not really stratifying on the hour. We just say, hey, what do we need for next day? This is just for next day only. So next day, if we current approach, we just put all this, the blue dots, all the uncertainty observed in the net load, the x-axis or the RTPD forecast advisory on the net load. So you have y-axis uncertainty, x-axis on the RTPD net load forecast. Then we just have one line, one cut, and say, hey, that's what we need. So from this, I will a little bit slow on this, is because you can see the histogram approach has the weakness is when you need it, you underestimate the requirement. When you don't need that much at the two ends, you overestimate requirement. So this is not good for the operation. So basically why this happening is because we have certain weather pattern we have not really utilized yet. And so this mosaic model, the new proposal, is trying to say, hey, we should overcome the, reduce this estimation, underestimation at the same time. So one stone for two birds. Go ahead, next. Next slide. So then we say, hey, because the current proposal has not using the weather information, just one line for every single observations possible. So we should use the weather information. Weather information, come on, there. You have so much available information available. Wind speed, solar angle, and the cloud winds, and all those. But for our uncertainty, we are using the surrogate, which is the on the RTD advisory forecast. The reason for that is all the wind and the solar and the load forecast, in the RTD advisory forecast, they already embedded many possible. You can imagine all the weather information there. So then that's readily available to the ISO. So then we say, when we talk about the weather information, is how we can use in RTD, find any pattern, possible uncertainty pattern against the RTD forecast, or surrogate the uncertainty against this the weather information. And just a side note, load is a little more complicated. They have a little more involved with other human activities, whether you are using the air conditioning, the cold days, or all that type of things. Okay, go next slide. Okay, so the quantum regression is a little different from the ordinary regression. Ordinary regression is trying to estimate the relationship between in the average. So basically, it's the average. What's the relationship of y in average of the x? The quantum regression is what we needed because we want to find what's the percentile, how much they cannot really, what's the relationship between the percentile of y over the x. And since we are finding the requirement, that's the cutoff, 95%, 97.5 on top, 2.5 on the bottom. So that's the quantum regression. Quantum regression is a spatial regression in the statistical modeling. And so we are going to use quantum regression because we are going to estimate the percentile. Go next. So I call this is called a smiling face. All these graphs are in this same shape, same formatting, and the changes are the x-axis and the y-axis. In here, the x-axis are the solar RTD advisory forecast, and the y-axis are the uncertainty observed in the solar. So and this is ISO for the for uncertainty, which can happen in the ISO observed in the 2021. And you can see if we just like first slide, the graphic we have, if we want to estimate what the uncertainty we need for tomorrow, for the solar only, then that's just one line for 2.5% on the FRD on the bottom. I use this FRD for this smiling face is because if I use that for the up, then you have the opposite is not smiling face. Smiling face carry a little more positive energy information there. Okay, so then you can see if I want to use the quantum regression for tomorrow, then we can see depends on what type of weather solar you're going to have tomorrow. You have different requirements depend on the weather what you have it for tomorrow. Then you have the, you see this smiling face? They really do the job, good job to cut this overestimating and underestimating. That's just one quadratic curvature provided in this model, quantum regression model is using the curvature. Then we found that this is very nicely handling this over and underestimating forecast. If EIM has solar only, so then you can very much advantage you can take of using this green line. And so this the takeaway today is hey, for the uncertainty observed in this each component, the green line is the quantum regression will be doing good job, better job than the straight line of red line. So I will say green is better for green. The green is better for the red and for this short. So if you want using some math, is SQ is green and SH, the histogram is the red. Q is for quantile and quadratic regression. H is for histogram. S is for standard for solar. Okay, this is spend a little more time on this particular graph. The next few will be a little faster because very similar. Go next. So this is the wind. The same pattern have a little smiling, not a really big smile, but a little curvature there. So basically for the on solar, if you in previous slides, if you have solar at two ends, of course you don't have much uncertainty. For wind, if you are solar, if your wind is smaller, there is not much penetration of the wind, then you don't have much uncertainty because in RTD I forecast 0. RTD I'm doing forecast 0 because so calm. And when the wind goes high, the uncertainty tends a little lower. However, the overall is more for the wind is more have the advantage of the savings of catch this under forecasting, over forecasting little curvature, and the wind is less. The curvature does not really have too much advantage over the the green is just a little better, not like the solar. Green is a lot better than the red. Go next. Solar it also has a little a smiling face here, and that's the same story. And green is better than the red, and LQ is better than the LH. And so this is the component. So I will for each of EIM, they have different profiles of the solar wind load combination. If you have does not have any solar, then you may be just not have a big much benefit you can get from this new proposal. If you have load, you just have a little bit. And if you have lots of solar, then that EIM may benefit more of this weather dependent on the requirement estimation. Okay, I will go next slide before I stop. Okay, so I stop for questions. Okay.
As a reminder,
so,
if you're connected to if you're connected to the computer audio or use the Call Me feature in WebEx, you may enter the question queue by using the WebEx raise hand icon located just above the chat panel. You'll hear a beep tone when your line is unmuted. At that time, please state your name and question. If you're just on the phone line and not using the WebEx audio, please dial #2 on your phone to enter the question queue. You'll hear a notification when your line is unmuted. At that time, please state your name and question.
Okay, so I take it as of now, there is not much question because we simply observed that the green is better than the red and Q is better than the H. So the mosaic model is, well, we want to construct a input variable to take advantage of all the components. Green is better than the red, and Q is better than H. So basically, we construct the variable is like this: we are going to use all the green line Q's and subtract all the impact of the H. So this is just a little edge of the green over the H. So we are going to perform the same quadratic mosaic regression. So this mosaic, I call it mosaic. There is no literature in the statistics. Is the mosaic regression. This mosaic regression is because I use all the different stones, all the little different components, and construct the new input variables to really take advantage of all the observed patterns and in the load, in wind, and in solar. Go next. And we may not really want to get into this much. Is this mosaic can look at the different perspectives, and if you rearrange it, then you have you see the reason why is this is kind of nicely constructed or contrived actually is the L minus W minus S is the net load. All the green lines have is the net load structure, and all the H put together have some interactions, modeled interactions, and all this. So we can pass this. This is not if you're math genius, then you can digest a little more and go next. So now this is continuing as a simple example of the previous. For next day, if we're using the x-axis, as I said, all the patterns or format are the same. Is x-axis and y-axis are changing. Here the x-axis are the net load, and the y-axis are uncertainty in the net load. So this is the first left is the first graph we have I have shown. Is if we say, hey, what would be needed for tomorrow? Then if you're using one histogram approach, this is example is the simplest assumption, just one requirement for tomorrow. Then this is the left, and you can see on the right is exciting. The reason is this: if you're using this combined the mosaic model. Combine all the components to the mosaic model, you can see they're really trying to cover all the potential uncertainties. If uncertainty is high, I use the higher uncertainty requirement. If uncertainty is low, and I use a lower requirement. So the mosaic model by this graph. Simplest model. I just want to use this to see, hey, this is doing reasonable job, and so don't have the much breakthroughs, and generally you have lower and higher. So that's why in the executive summary, you requirement on the average is the same, but this average requirement does not reflect the attempt. The success or attempt of the mosaic model trying to adapt the weather information, trying to see what the type of load and wind and the solar can supply to change adapt this the requirement calculation. You can see this on the right side of the green dots on the requirement calculator mosaic. On the left side is one histogram approach. So this is really trying to adapt this weather information. Then on the right end of this right graph, there are little spots of this dots. It's basically the estimated is high, but not that many are high. Not like they're on the left part of the right graph. They are really condensed because many of these have the lower uncertainty, and then we need this lower requirement. So go next. So next slide, please. Hey, what happened to this? Okay, so for the stability of regression output, even though we can cover a little more of the uncertainty to prevent the breakthroughs for the original mosaic model. But the mosaic model, when you run we needed to have the cap to prevent the outliers, to prevent to get a little more stable regression output. So the final proposal is we need the cap and plus additional threshold to cap this the regression output. So next, please. And now, this, as I said, you have to every pattern or every format of graph format are the same. The x-axis are changing. Here, the x-axis is the load for RTD forecast, and the y-axis for the next few graphs slides or the net load uncertainty. So you can see the load is also, when you plot this against the load, you can see on the right side you are trying to adapt, and on right side of the graph trying to adapt what type of load you have, and you have the patterns on the right, the green dot uncertainty. They really cover a little more. They have the breakthroughs. The breakthroughs is because we are doing some caps of this, but you can see the right end of right side you have much not a stance. You have some. You can see some the load of and on the load become the net load requirement. You can see some of these dots on the right side trying to adapt to get the lower of requirement. On the left side of the graph, you see that little shape of little curve shape on the left side of right graph, the green, trying to adapt how much the load is changing. You can see the uncertainty changing a load at the left end is a little curved, and our requirement is also a little curved. So next slide. Thank you. And this is wind. Wind is for the ISO. We have load profile. The wind is not as impressive as the other two, because it is a load. The wind is not have the profile in the percentage wise in the ISO is the smallest, and so the pattern is not significant as I showed before. The smiling face is not really smiling, but you can still see on the right end you still have some trying to capture some bigger ones. Okay, go next slide. Now you can see the solar. For this simple example, this is not just one requirement for next day. And if you want to stratify by 24 hours, then you have 25 hour value on the right. On the left side, you have some different pattern. But I use this just one value for tomorrow. Is just use this example to illustrate what the mosaic model can do. So you can see this adapted this solar pretty well. If it's not capped, it's just so kind of perfect to adapt the solar condition. But we are using this cap, then we have some breakthrough or exceedings. So next. Now I stop for the question.
As a reminder, if you're using the computer audio or use the Call Me feature in WebEx, you may enter the question queue by using the WebEx raise hand icon located just above the chat panel. You'll hear a beep tone when your line is unmuted. At that time, please state your name and question. If you're just on the phone line and not using the WebEx audio, please press #2 on your telephone keypad to enter the question queue. You'll hear a notification when your line is unmuted. At that time, please state your name and question.
Thank you. So I need to take questions at the end. This is the simulation study the ISO conducted recently, and we have as I said, the different EIMs have different profiles. The percentage on the 3 columns on the table on the right end, you can see different wind percent, different solar percent, and if you have solar percent in terms of your profile, then you will benefit more, and you can see more advantages of this. If you don't have solar, then you pretty much the histogram and this will be not as impressive. So this is all the EIMs put in the study, and we noticed that each different EIMs we have some old friends, there's some new friends, some new friends we colored, so they have different the time days spent was in the simulation, and the conclusion is the same. Does not really depend on the days the EIMs in the study. And this simulation period is for last year. The historical data we are using for 2 years, and the sampling scheme we have 3 different sampling schemes. This is using the second one. We have tried. The ISO has tried different models. Of mosaic model, I tried different other model and the quadratic the model, and try different schemes, and we are still involving the process how it will go. And this simulation study. This is not as simple as the examples I showed before. This study is for each is the production fashion. That means for we are stratifying all the regressions, all the histograms by hour. So any comparisons between histogram and the mosaic output is really in the production fashion. What is going on for using the 180 days previous and moving this day and tomorrow, you have different sampling pool for training the model and all those. So this is the production. It's not as the same as the examples I showed before. Okay, go next slide. This is in the paper we published. We select the day and to showing how this difference between the histogram and the mosaic output of the requirement for each EIM, select one day, and also comparing for that comparisons of histogram and the mosaic. We put this what's the load condition and wind condition on the right. So you can see the for this graph, the 2 red lines are histogram approach provided the requirement for each hour. You have different for the 1 day. You have 24 different requirements, and for the mosaic they have the 96 because each 50 minutes you may have different the weather conditions depends on your forecast. So the you can see all the dotted line is the mosaic output. On the red, on the blue lines are the observed uncertainty. So you can see how well the mosaic requirement is estimating, adapting this uncertainty. You can see when during the middle of the day, this wind is a little low, on low end. You don't have much requirement. Solar is high. You remember 2 ends. Then the uncertainty is kind of approaching to 0. Then our requirement in the middle of the day is approaching to 0. When the wind picking up at the end and solar load is gradually go down, you may have this higher requirement. Then they're going to shooting back. So you can see daily graphs are showing what the really operationally each day, what's the how adaptive the all the mosaic and histogram approach is. So you can see the hour in the afternoon, you have really big requirements for the ISO 3,000, but actually we may just need 2,000. So this is kind of savings on the requirements, and the coverage does not impact much. That's the executive summary. And so go next. So how do we perform to evaluate the performance of each of the mosaic versus histogram? We just experience just put these 4 different criteria in the measurement of the performance. And here I need to note all these are the measurements on the average. The average is the coverage is about the same, and the requirement is slightly going to save is the how much your estimate requirement is. You can look at this previous daily graph. You can see the more adaptive they are, the have little less requirements overall. Then they are more close to the blue lines, or the dotted line is closer than the red lines. They are closer, and the exceeding is comparable. So basically, after this, this is pretty much in the executive summary. After we incorporated the weather information with less requirement, we achieved on the average whatever the histogram has achieved before, and they're more adaptive. There is no measurements really to show this how adaptive it is. You can look at the daily graph. You can see how really changing according to weather. And the reason for that, the adaptive is the mosaic model directly utilize all the patterns found in the solar, in the wind, in the load, and that's the criterion we use. And the next slide. And all these are the tables, 98, 97, 97, 90, all this. So you can make comparison, and FRU is FRU, and of the requirement, H is the histogram, M is mosaic, and they're comparable. They are a little less coverage because the mosaic, the histogram always have when you have the observed high value of the uncertainty, they will carry long period of time, and mosaic is a little more depends on the weather, so they have this little less coverage. Actually is I would say is a little plus, because they have less impact of outliers observed in history. In histogram, you tend to have more of that. Okay, go next. This is the requirement. You can see generally in the ISO you have on average you need 1142, and this is just 1042. So it's generally about some average about 10% or 5 to 10%. Some of some EMs have this statistically is comparable. It's nothing much, because it depends on the, as I said before, depends on what type of the profiles you have. So next. And this is closeness. You can see, and for the ISO, the ISO, you have 891 measure the distance between the observed uncertainty to the requirement, and you have this just about 800. You have about 10% of closeness for the ISO, and some APS have a little more than 10%, some are less. And generally, this is just showing this the mosaic is doing reasonable job to after adapting this weather information. Go next. And the exceeding is comparable. And some of this model we are experiencing some larger exceeding, and we have some other model reduced have less coverage, and we are going to see, because it depends on the weather, is to have this depends when you need it. Whether is exceeding when you have the lower end, when you have up end. So we are going to make more study to investigate, but we currently do have some other models to have both similar comparison of the coverage and less requirement and more have closer distance between observed and the requirement, and as well as the have less exceeding numbers, have less the breakthroughs. We are doing some study to see how it will go in the future enhancement of the model to choose. Go next. So now this is the seasonality. The seasonality on the left is the histogram approach. On the right is the mosaic approach. The x-axis here is the month. So you can see on the left, on the mosaic, on the left, the histogram approach, because on the in the June, if you observed, you want to get the what is the requirement needed for in June, for any day in June overall, you are using all the January, February, all these have less solar, have less load, then you tend to underestimating the requirements. And in the winter, if you're using all the summer, then your coverage is higher. Then because all the observed solar or is from historical data have all the larger the variance, the larger uncertainty. Then of course, if you're using the larger one to estimate, then in winter time you will going to cover a little more. So, but you can see this seasonality was reduced by the mosaic or any other regression, because you have some weather information. Depends on the weather information is high or low. They do have an advantage of using the regression using mosaic. So all these comparisons are really showing the mosaic model doing reasonable job. ISO is also searching if any other model can really doing better, and we experience many different models, and this is the final one choosing. From the structure of this model, mosaic model, they have certain structures embedded in the mosaic variables. You can, if you take a different look, and then you can understand the mosaic a little better. So why all this can be achieved by the mosaic model. Okay, go next slide. So we, as I said, you have ISO has trying to get a further enhancement on different better, trying to search better model, better sampling scheme, and we experienced this is just one a small set of the we experience. Currently, we propose the sampling scheme 2. And it's like you fix 100 days, and you have the different weekdays and workdays to put it together. And you have the the histogram is using sampling scheme 1. It's using this 40 days and matching 40 days. You have 14 days. If your weekends, you have 40-day weekend. Or if your weekdays, you have 40 weekdays in the training sample. And if your weekends, you have 20 weekends to matching to. This is current approach to the sampling. Then you have a different ones. You have you can use the forward and using the backward and they combine this. If today, if it's April 1st, today is April 1st. I'm serious. Okay, it's not April 1st. Today, April 1st, we'll be using sampling scheme 3 is using the March 1st to, for example, March 1st to the March 31st, 2022, as well combined using April 1st to April 30th, 2021. So kind of balance out this some angle at different weather conditions and trying to so this is a different sample scheming we are studying, we are investigating as of now. Go next. And you can see the I have shown the seasonality of these green lines as the sampling scheme 2, and the blue lines is sampling scheme 1. That's currently using this 40 days. You can see the really so significant impact by seasonality. But the sampling scheme 3, you can achieve the more stable for the mosaic, and they reduce this really the seasonality really doing good job, and we will put that consideration into the future enhancement. Then you go next. And some other thresholds. This is one of EIMs one day. You can see, hey, the estimation is just shooting to the roof. The reason is you have that EIM for in the past 180 days, you have the outliers. Outliers 99% really the cap. When we're doing the cap, you remember we're doing the cap, and it does not really cap that outliers. So there were two fronts of this. First, the EIM needed to be get rid of the outliers and closely really monitor the outliers to supply the load forecast and all these forecasts to the ISO to reduce the instances, the occurrences of this type of runaway estimate. On the ISO part, on the modeling side, we may need to put an additional threshold. Is like I said, for this particular EIM, for the overall year, if the maximum kind of quote unquote exclude the outliers is around 300, then we use 300 to prevent these runaways. And so this is some we're going to put this Then they also not really runaways. You see for this EIM as well, all the ones we can see the lower end of this dot of the FRU dot is the approaching to zero. When you have zero, of course it makes sense because observed uncertainty are negative, you have the zero. But that's not necessarily true because some positive observed, you still have some negative, zero requirement. So we may need to put a kind of floor of the requirement. So this is also a studying area currently ISO is conducting. So go next. This is just acronym and everything. So I pretty much concluded my reporting to you, and maybe I'm too fast, and so waiting for questions.
As a reminder, if you're using the computer audio or the Call Me feature in WebEx, you may enter the question queue by using the WebEx raise hand icon located just above the chat panel. You'll hear a beep tone when your line is unmuted. At that time, please state your name and question. If you're just on the phone line and not using the WebEx audio, please dial #2 on your phone to enter the question queue. You'll hear a notification when your line is unmuted. At that time, please state your name and question.
Okay, so you can submit the question into the to ISO, and we can later to discuss. I'm approaching to the end of this hour, and so.
Hong, there is a caller in the queue.
Yes, Robert.
Please go ahead. Your line is unmuted.
Hey, Hong, this is Robert Fisher with Nevada Energy. Great presentation, and I appreciate the presentation and the slides. I saw some data in regards to the individual EIMs and some percentage changes. Is it possible to see something in regards to the changes between the histogram and the mosaic on, say, a monthly basis, or just so we can kind of get an idea what the changes would be?
No, that's interesting. We may need to talk offline, but the monthly changing is the, yeah, we can supply that information. Thank you.
Thank you, Hong.
Also, I see a question in the chat that came a while ago. So it says, does the load conformance value impact the load forecast that is used in capacity test?
No, right now it's not included in the load used in the test.
Okay, and there's one more comment as well. It says this discussion suggests that a chained event series evaluation may need to be undertaken to the extent that a given conformance action is subsequently undone by a future conformance action in the opposite direction. The validity of the initial action might arguably be called into question.
Sorry, I couldn't catch the question. We will address it in the next round.
Okay, I do not see any callers in the queue or anything in the chat.
Thank you.
Shreyas, next slide, please. Thank you. As a reminder, please submit comments on the analysis and meeting discussion by April 15th using the commenting tool linked on the initiative webpage. If you have any questions, please contact ISO Stakeholder Affairs at CAISO.com. Next slide, please. Before we close today's meeting, the ISO is pleased to announce this year's Stakeholder Symposium, which we held in person at the State Credit Union Convention Center in downtown Sacramento on November 9th and 10th. Registration for the event will be open in May, and a public notice will be issued once the site is available. Additional information is available on the Stakeholder Symposium webpage on the ISO's website. If you have any questions, please feel free to contact us at symposiumreg@CAISO.com. Thank you for joining today's discussion. As a reminder, this meeting was recorded for informational and convenience purposes only. The video file will be posted on the initiative webpage for a limited time after this meeting. We look forward to receiving your comments and have a great rest of your day. Operator, you may now conclude the call.
Thank you for using event services. You may now disconnect.